For topic two, we're going to look at converting between US and metric when we're dealing with weight. Okay, so when you convert between the two systems, you do have to use dimensional analysis, and most of the conversions that we're going to use are approximations. So just know your answers are going to end up being usually some like rounded, approximated decimal value. Okay, so for example two, it says perform each conversion, include correct units with each answer. I did not specify any rounding, so I've said this several times now. If directions specify to round to a particular place value, by all means, round to a particular place value, especially in Pearson, okay? If directions do not specify specific rounding, one or two decimal places is generally perfectly appropriate. With money, just know that unless stated otherwise, money should always get two decimal places, okay? Now, for us, we're going to talk about initially pounds and kilograms, and then we're going to talk grams and ounces, okay? Now, we will need conversions for these. So let's go to the conversion sheet and find a conversion for pounds and kilograms, and then another one for grams and ounces. Let's see, conversion sheet is here. All right, so we're looking at English and metric equivalents, okay? So we needed one for ounces and grams, and we have here that 1 ounce is approximately 28 grams. And then we have that 1 pound is approximately 0.45 kilograms. So those are the two that we're gonna need for example two, okay? So let's go back to the worksheet. I do apologize for flipping back and forth. This is just the best setup I have for my technology. It's not ideal, but it gets the job done. Okay, so we need to remember that 1 pound is approximately 0.45 kilograms, and 1 ounce is approximately 28 grams. Those are the two conversions we're going to need for these two problems, okay? So let's say we have 120 pounds. We're going to start with what we know. We have 120 pounds over 1. We're going to multiply this by a unit fraction relating pounds and kilograms, and that's what we use the conversion for. All right, so we have 1 pound. I do want pounds in the denominator and kilograms in the numerator. So I have 0.45 kilograms over 1 pound. The reason for that is I need the units pounds to cancel, and they now do, leaving my desired unit kilogram in the numerator. We clean this up a little bit and we get 120 times 0.45 kilograms for the numerator. Denominator is just 1, which doesn't really do anything for us. And then we can go to the calculator. So we want to do 120 times 0.45, and we get 54. So no rounding necessary at all. So this is going to be approximately 54 kilograms. Okay. Now, even though our calculation was exactly 54, the conversion was not exact. We said 1 pound is approximately 0.45 kilograms. So this is still an approximated answer, but we can go ahead and just say it equals 54 kilograms based on our numbers. All right, next we have 500 grams. We want to convert that to ounces. So start with what you know. 500 grams. We want to create a unit fraction from the conversion, which is 1 ounce is approximately 28 kilogram or 28 grams, excuse me. All right, we want grams in the denominator and ounces in the numerator. We want to make sure that the unit gram cancels, leaving my desired unit ounces in the numerator. Clean things up a little bit. My numerator is 500 times 1, or just 500 ounces, divided by 1 times 28, or 28. And then you can go to your calculator for this one. 500 divided by 28, and we get 17.8571426. It would be absolutely absurd and ridiculous to give me this answer unless I asked for this answer. So this is what I mean. Like, if we don't specify rounding, use your head. 6 or 7 decimal places is not the norm. 1 or 2 is fine. So let's say we go 1 decimal place. So that would be this 8. We want to round to the 10th place. Looking to the right of that, I have a 5, which tells me to round up. So I would add 1 to the 8, and then I would chop everything after that off. So I would say this is approximately 17.9 ounces. Okay. And there you have it. That is converting between US and metric where weight is involved, right? Let's look at two more examples, or well, one more example, but it has two different parts. And one part three parts, so a few more examples. All right, example three, it says word problems include correct units with each answer. All right, so first up it says an aquarium holds 0.145 cubic meters of water. How much does the water weigh? Now, when it comes to liquids, you do have to be careful because, believe it or not, different liquids have different weights. This one is very specific to water. We know an approximate weight for water. Now, if we were talking about milk or orange juice or some other kind of gooey fluid, it would be different. But for water, we have conversions for that. So let's go to the conversion sheet. Remember, we're looking at cubic meters and water. All right. So right here, we have volume and weight of very specifically water in the metric system. So we had a cubic meter, and we need to know how we can compare that, like as far as like weight is concerned. So 1 cubic meter is equal to 1 kiloliter. So that's like 1,000 liters. And that has a weight of 1,000 kilograms. Okay. So we're saying basically 1 liter of water weighs 1 kilogram. Okay. So we have 1 cubic meter is equal to 1 kiloliter, which equals 1,000 kilograms. Okay. So let's go back to our worksheet. So we had that 1 cubic meter is equal to 1 kiloliter, which weighs 1,000 kilograms. And that makes sense because, I mean, imagine a liter of soda. Okay. Now, soda's not water, but imagine. Okay. If you had 1,000 of those, okay, that's 1 kiloliter. So 1,000 liters is 1 kiloliter. That's going to have some heft to it if you're talking water. Okay. So it would make sense that this is 1,000 kilograms. Okay. So let's see here. We have 0.145 cubic meters. So 0.145 cubic meters, okay, over 1. Now we know that is exactly the same thing as 1 kiloliter. So I can go ahead and just say that equals a kiloliter. So for each meter, I have a kiloliter. So 0.145 cubic meters is going to equal 0.145 cubic or 0.145 kiloliters. So we can go ahead and start converting this here. Okay. So we can say this is 0.145 kiloliters, and we want to convert that to kilograms. Okay. So I know that 1 kiloliter weighs 1,000 kilograms as long as we're talking about water. Okay. Kiloliters cancel, leaving kilograms, which is a measure of weight in the numerator. So I clean it up, and in my numerator, I get 0.145 times 1,000. And the unit of measure is kilograms. And then in my denominator, I just get 1 times 1. So if you can do 0.145 times 1,000 in your head, great. If not, use your calculator, but you should get 145 kilograms. So if we have 0.145 cubic meters, that is the same as 0.145 kiloliters, and that would weigh 145 kilograms. Okay? So be careful with those. Some of those can feel a little tricky. Now, this last part for this video, we're going to talk about a dosage of medication. Okay, so it says the prescribed dosage of a drug is 6 milligrams per kilogram. So for each kilogram of your weight, you need 6 milligrams of this medication, and you need this daily. So 6 milligrams per kilogram daily. How many 200 milligram tablets should be given each day to a patient who weighs 150 pounds? The very first thing we have to do is we need to convert this patient's weight to kilograms. And this is a common thing. A lot of medications are going to give you, the dosage is going to be given to you. So, wow, bless my heart. The dosage is going to be given to you as some measure of medication per kilogram of weight. That's very typical. So it's not uncommon in the medical field to convert weight to kilograms. So let's do that first. So what you need to remember is 1 pound is approximately 0.45 kilograms. So we're going to do the weight first. So I have a 150-pound patient. I need to convert that to kilograms. So I need to multiply by a unit fraction that relates pounds and kilograms. I need pounds in the denominator so that they'll cancel. So 1 pound, 0.45 kilograms. Pounds cancel, leaving kilograms in the numerator. I'm going to skip some of the side work here. We're going to just get right to it. 150 times 0.45. So let's see, 150 times 0.45. You should get 67.5 kilograms. So this is the weight of our patient. Well, that's great. But how much medication does this patient need? For each kilogram of weight, they need 6 milligrams of medication. We were given that up here. So we want to take their weight in kilograms and multiply it by 6. That's going to tell us how many milligrams of the medication. So we get 67.5 times 6. And using your calculator again, you should get 405. So this patient needs 405 milligrams per day. Okay? So we had to start by finding their weight in kilograms, figure out then how much medication they need for the whole day, and now we have to figure out how many tablets this patient needs. So the tablets for this particular medication come 200 milligrams per tablet. Okay? So we want to take the total milligrams needed and divide it by the milligrams per tablet. So we're going to end up getting just a teeny tiny shave over 2 tablets. So we need 405 milligrams. The tablets come 200 milligrams each. If we take 405 and divide it by 200, we get 2.025. Well, let me erase that properly. That looks messy. So we end up getting 2.025 tablets, but that's not super likely. Can you imagine going to the pharmacy and being like, yes, pharmacist, could I please have 2.02 milli or 2.025 tablets? No, that's like a little pinch off of the tablet. So we're going to say this patient gets 2 tablets a day. It'll be a teeny weeny tiny bit less than they need, but it should be negligible. Okay. So we'll say this person 2 tablets a day. Okay. Now that's it for the weight measurements. Okay. In the next and last video for this chapter, we're going to talk about temperature, which is super easy to convert.